Hello, everybody. Welcome back. It's Brian and Miss Berlin for Breaking Down Security.
Hello.
And as you can probably hear, I'm at my office in a very, very small conference room. But we had to, this is one of our interesting During the Day podcasts because our guest this week is in the country of Israel. And I'm going to go ahead and let him pronounce his name because I don't want to screw it up again.
Come on, Brian.
No, shut up, Miss Berlin. Dang it. Anyway, so I'm going to introduce Omer to the show, and he can give his whole name. And what we would do at this point, I'd like to get a little background and tell us a little bit about yourself.
Hi, Brian. Hi, Amanda. Thanks for having me. It's my pleasure. So thank you very much. So yes, you pronounce it well. My name is Omer Levi Hevroni. And as you say, I'm from Israel. So also thank you for doing an early episode. So it will be in a time that I can join. So I'm working these days at Soluto, which is an R&D center for a big US company called Assurance. So we're located in Tel Aviv, and we are part of a bigger US company. And I'm working there for the past 4 years. And today I'm doing all the things related to DevOps, DevSecOps, AppSec, all the fun things. At least I think they are fun. And I get to all this field of security by accident, actually. I didn't start as a hacker or something like that. I did was a computer geek from really young age, but not a hacker. It happened because my company started a security champion program, and I joined this program, and actually I got hooked by security, and this is what I'm doing until today.
Nice. Okay, and so what's your title there at Soluto?
Title is hard.
Nice.
When I have to, I think the last one is DevSecOps engineer, although I'm not sure what it's saying. Like, I'm not sure what's the meaning of DevSecOps engineer, but no. If I have,
it's just a lot of titles thrown into one because they don't know either.
Yeah.
Other jobs as needed. So one day you'd be crunching code, you're an InfoSec guy the next day, you're collecting trash on the third day, just kind of like when I was in the Navy. So yeah, very cool.
Yeah, but it's look good. It's look good on the card. So
right. Okay. Very cool. All right. So we had you on one because I believe you reached out a couple months ago and said, "Hey, I'd love to come on and talk." And normally, when I get solicited to these things, the first thing I think of is, "What are they selling?" And in this case, you're not selling anything. You actually have a tool, and you talked at AppSec California in January of this year about this tool, and it seemed like a very interesting talk. Because we've done, at least at the beginning of this year, we did a lot of discussion about Kubernetes and Kubernetes security. So we had Ian Coldwater on, for instance, to talk about hardening your Kubernetes. And, we've talked about NPM and Docker and other systems that are used in DevOps and need to be secured. And your company came up with a solution that is open source. It's free. So, we're not here to sell anything. There's other options that are available out there, but yours was the first one that came out about storing secrets in Kubernetes. Why would we need to store secrets in the Kubernetes environment? What is secret about the Kubernetes environment?
So, secrets are the fundamentals. Sorry, I will restart. Secrets are the fundamentals of any application development. It's very hard to write any service, any API, or even any function that doesn't require database credentials or API keys or private keys or whatever. It's very hard to imagine a process that doesn't need that. And usually when you have such kind of credentials, you want to make sure that only your application have it and no one else, because they're usually very sensitive. And if someone have them, they have all the permission your code has. So this is why we want to have a good solution for storing these secrets. And we had a specific angle that make it even more interesting because of how we work at Soluto. We want to work in a way that let developers do everything, from writing the code to deploying it to monitoring it, which basically the idea of DevOps and no silos and all that. So the combinations of letting everyone do everything and building a really secure solution is not an easy challenge. But this is what I like about my job. Always find the right balance between giving as much permission as possible and still staying secure. And this is why we try to find a good solution that will solve that. And Kubernetes got involved when we started the shift to Kubernetes a year and a half ago.
If you could explain manifest files, because I don't really know, like that. This is probably one of my bigger weaknesses is Kubernetes stuff, and a lot of the stuff that you're covering. I'm sure I'm probably not the only one. So yeah, if you can explain those, that would be helpful for me.
Yeah. So the manifest files are just YAML or JSON files that let you define Kubernetes objects using configuration files, which let you do GitOps, the idea of managing all Kubernetes infrastructures using Git. So you can have a file that say, hey, I want a pod. Pod is like the basic element of Kubernetes is the thing that actually run your container. So you can say, I want a pod, and this pod should run this Docker image, and it should have this port, and all the things that are relevant to a pod. And the same can go to any other Kubernetes object. So the manifest files are what enable GitOps for Kubernetes. And you can also use manifest files to create Kubernetes secrets. So Kubernetes has an object that can store sensitive information called secrets. And you can create it using this manifest files.
Okay. And in your talk, you showed in the manifest that usernames and passwords are stored typically in these files, but they're not stored securely, which I found quite odd that Google would go through all this and get all this set up and then do something like that. Maybe you could tell us about what kind of deal is going on in the manifest files that would require that kind of encryption or secret monitoring.
Yeah. So the Kubernetes team put a lot of effort to make these secret objects secure, so you can use them to store such sensitive information for things like API keys and other things I mentioned. And there are a lot of protections around these keys, including encryption at rest and RBAC and all the good things you want. But as you mentioned, when you want to do GitOps with secrets, you need to create the manifest files. And in the manifest files, the secrets are just encoded. They are not encrypted. And they're just encoded because the manifest files does not have any layer of protection by design, by Kubernetes. So they are encoded just in case, you want to put something that is binary or something like that. So you have to have some sort of encoding. And this makes it really easy to create secrets because there is no overhead of encryption, but it also face a new issue of how you store those manifest files. So you have a manifest file represent your secret, but where do you keep it? If you put it in Git, anyone with access to Git have the raw secrets, and anyone who cloned the repository have them. And this is a really hard problem of Kubernetes secret. And as you mentioned, there are a lot of different solutions. There are a few different solutions that let you take these raw Kubernetes manifest files and wrap them in encrypted forms. Things like sealed secret or Helm secret. So basically you have a similar manifest, which could be called like sealed secret, and you have a very similar secret, which is encrypted and not encoded.
Okay.
And then you can store it, all that.
I see. Okay. I think what I was thinking of with tickets was service tickets, is what I was thinking of. So service tickets are what are generated by the manifest?
I'm not sure. I still don't recognize the term. It doesn't. Sorry, the tickets are just. Sorry, I will restart. The manifests are just sent to Kubernetes API. Kubernetes API can parse them and create the relevant objects from them. It's like goes directly from your computer to the API.
Right. Okay. All right. Nice. Okay. Yeah. So let's go. Let me grab the notes from the. Okay. So in your talk, you talked about something called a super dev, and that would be what somebody who has. Would that be like a dev lead or somebody like that? Why would we need a super dev using this environment that you're wanting to set up?
So this is what I started with. I said that super devs are all the developers we have at Soluto devs that have full responsibility of their code, from writing the code to deploying it and also monitoring it. And this is why it's a challenge, because you want to have a secure solution that still allows the dev to do whatever they want.
Okay. So super devs aren't like the gatekeepers. They're not like dev leads or anything like that. They're just somebody who has access to everything from start to finish.
Yeah. I use the term super dev because I couldn't find any better term. We had an internal discussion about naming, and this was the best one.
Makes sense.
Kind of like a super admin when it comes to.
Yeah. Yeah, like a super admin. That makes sense. Yeah. Okay. All right. Let me see. So Omer has requirements for storing his secrets, and you actually had a slide, which I'm actually making screenshots of the slides as I was going along. But so you have specific requirements: must support git-ops, must be native in Kubernetes, and must be secure. And one of the sub requirements for being secure was one-way encryption. So if you encrypt it with one-way encryption, how do you decrypt it on the other side when you're done?
Yeah, when it's like it's not really one-way encryption, but the idea is that once a developer encrypted the secret, she cannot decrypt it back. There is no the permission the developers will have is only encryption because there is no need for them to decrypt, and this makes the attack surface a lot smaller. So the only way to get the raw secret itself is by connecting to the pod. There is I don't want to have any other attack surface that let you get the secret. This is the idea behind one-way encryption. It's like almost one-way encryption. It's not hashing.
Right. Okay. Okay. So let me pull up some of the other slides here. All right. So you talked about in your solution a couple of tools that we had. One of them was using the Kubernetes native version, and you went through and you threat modeled it. You talked about the code, the manifest files getting added to GitHub, and then the pods are created. Why was the Kubernetes native such a problem for you?
So we started talking before about the problem with the manifest files that you store them on Git, and this is one problem. And the second problem is how you're going to consume the secrets. You're probably aware to the huge dispute about environment variables, whether or not it's a good idea to store sensitive information in environment variable. Where do you stand in this dispute? Like, do you like environment variables for sensitive information, or you are strongly against it? Do you have an opinion on this dispute? Because I find a lot of different people have a really good argument for both cases, like for using them and for not using them.
I've never actually used Kubernetes before, sadly. So I don't come from a development background.
Like you have a VM and you have something there that need API key, and what your position about using environment variables to pass API keys, for example, to a code there.
Right.
This is like the question.
Yeah, you don't want to be keeping them in a flat file, and we've heard stories about people who've uploaded their API keys, or if you've done any kind of pen testing with code repos, you can search for AWS keys, or you can search for API keys. So uploading those into your GitHub is probably not a good thing. So you wouldn't want to be storing those in files that could be uploaded.
Yeah, I mean, I know a handful of people that have just scripts all the time searching GitLabs and GitHub and everything else for different environment variables and API keys. And I mean, when I was learning how to do Git, I know I uploaded one on accident, or, like my first time using it. So it's definitely common, I think.
Sure.
Yeah, and I think this is why a lot of people are trying to use environment variables, because I'm often thinking that it's a bit easier, it's a bit more secure because you can inject it in the CI. And this is a big part of the dispute, like which one is worse, having your secret on the file system or having your secrets on environment variables on a VM. What is more secure?
Right.
And a pretty good argument for both sides.
Well, ideally, they would use something like an HSM or a key management system, right?
Yeah, but you still need credentials to access those systems. Like you can have an external system that stores those secrets, but you still need to interact with this system. So you can use things like AWS Assume Role, but it's still things that you must have on your machine.
Oh, I see.
Yeah.
Okay.
So this is part of the problem of using Kubernetes secrets, because you need to decide how you want to consume your secrets. Whether you want your secrets mounted into the pod as a file, or you want them mounted as an environment variable. And the environment variable is a bit easier, but again, there are a lot of people who think, and I can say that I also think it's not a good idea to use environment variable for sensitive information. So you have to go with files. And files usually make things a bit more complex when you want to have multiple secrets, because of how Kubernetes lets you mount secrets. And so this is a different issue with Kubernetes secrets. So we have two issues. The first issue is how we store the manifest files. And the second issue is how we consume these Kubernetes secrets into our pod. Does that make sense?
Sure. Yeah. So one of the things you mentioned here in encrypting secrets, you mentioned something called Helm Secrets and sealed secrets. I laughed at the seal that you put in there, of course, but maybe you could tell us a little bit about what Helm Secrets are. I know that there's not a container, but it's like a framework to install applications. Is that what we're talking about with the Helm Secrets, or is that something else?
Helm is like NPM for Kubernetes. It's let you install things on a cluster. It's as secure as NPM. Helm Secrets and Seal Secrets are probably the most popular solutions these days for storing Kubernetes secrets on your cluster. The interesting facts are that Seal Secrets, for example, the solution uses one keeper to encrypt all your secrets in the cluster, and this keeper is kept in the cluster, which make it a bit insecure. You usually don't want to keep the key you use to encrypt secrets in the cluster. You want to use HSM for that or something like that. So this is not supported by Seal Secret. Helm Secret does support HSM solutions, but it also requires coupling to Helm. So it's let you encrypt the secrets and decrypt them right before giving them to Helm. So these are the two main solutions, but both are imperfect.
I see. Okay. I have to figure out. Oh, there. Yeah. Oh, I don't want to make it full screen. I'm looking at your SlideShare stuff. So I was looking at the format for the sealed secrets stuff. Looks like it's in a JSON format.
Yeah, it could be Kubernetes support both JSON and YAML. So what I put here is a JSON, but it could be also YAML. And it's look very much like a Kubernetes secret, just instead of base64, it's encrypted. I think it's RSA with envelope encryption, but I'm not 100% sure about that.
Mm-hmm. Okay.
But yeah, it's encrypted in, military grade. I think this is the common term.
Right. And you said that some of the issues are coupling to a specific cluster or deployment method, and any change to the secret requires decryption. I guess that would make sense because it's not, you can't just change the secret keys all of a sudden if they've got leaked or something like that. So you'd have to decrypt everything and then re-encrypt it with a new key.
No, it's more like, let's say you have a service and you have an API key A, and you created this API key and you encrypted the secret, and now you want to add another API key or another DB password.
Oh.
So to do that, you usually have to decrypt the secret, add the new one, re-encrypt, and it's not an easy process, and it's not the one-way encryption that I wanted.
Right. Yeah.
Which is a bit problematic, and you go back to permissions and all those things.
Okay. All right.
And I really like, so you also have listed in here the threat model for Kamus. I really like, I mean, it's pretty thorough when it goes through all the different the threats and controls that are in there. I haven't gone through all of them yet, but I mean, there's like certificate pinning in here, which not a lot of places do. Good things like, blocking anonymous internet access to it, credential hardening. A lot of stuff in here that we don't see like from other pieces of software.
I think our responsibilities as open source maintainers is give our users all the information they need about how to use this application securely, especially when we are going to talk about solutions that are security related features like Kamus. And I think Kamus is one of a very few open source that have threat modeling, and I hope to see more open source projects having this, because the threat modeling is how the person creating the tool can tell you, the user, what you need to do in order to use it securely, and share with you the different threats, so you have full understanding of the security of the tool you need. And this is why we decided to do it. And I really hope to see more projects doing it.
Yeah, I'd like to see everybody do their own threat model. That would be great.
Well, you're also getting free pen testing because people are going to be like, yes, let's go and play with that. So when you're encrypting everything, what's the format you're using? Because obviously the base 64 version in native Kubernetes is not going to be good enough. What did you guys decide on for either a hashing algorithm or encryption algorithm?
So the idea behind Kamus is to build a small wrapper around existing cloud encryption solutions. So Kamus can wrap either GCP KMS, AWS KMS, or Azure Key Vault. And all the three solutions are very strong encryption systems. I have all of them. I'm not sure about AWS, but I think all of them support HSM. In AWS and Azure, we're specifically using RSA. In GCP has full control about it, so it's AES. So in AWS, it's also AES. I was confused. In Azure, it's RSA. In GCP and AWS, it's AES, and it's pretty secured and pretty strong. And this is the idea behind Kamus. But the more interesting part is how you encrypt. Kamus lets you encrypt a secret for a specific application. This is the entire idea, and what makes it, in my opinion, a game changer. The idea is that you encrypt this secret for a specific application, for your specific application. So, for example, if you work on something and you encrypt a secret for this application, and Amanda also working on something, she cannot use this secret and decrypt it. She will have to re-encrypt, and this is the foundations of the Kamus, of the security of Kamus, and what make it really different from other solutions. And currently we are mainly supporting Kubernetes, but the same solution can apply to regular EC2 instances or to functions or to anything else that has an identity. And like this is the long-term vision of Kamus, to support other platforms. And we hope to get there someday.
Okay. So you had gotten down here something called the environment variable dispute, and you're saying some of the cons of that is log libraries collect environmental variables, and we talked a little bit about environmental variables before. Everything's accessible via proc. It's visible when inspecting a Docker image. I didn't know that. Okay. You can have RCE. Those are the big four. Yeah, that's pretty good. So some of the pros seem to be fairly good. You can't commit those accidentally. Simpler than files, and you can. So it's interesting. You put a con as accessible via proc, but you also put a pro as there. If you can access proc or inspect them, you can inspect the mounted volumes. Why is that? Why is being able to access proc in that a pro versus having the accessibility to proc being a con in the first place?
So I put both because I try to get like all the different cons and pros from different peoples and put all of them straight. Mm-hmm. And I think there is a good point about if you have an access to the machine and go to /proc, you can see all the environment variables or this process is using. But it's also true that if you're already in the situation that a hacker has access to /proc, this hacker probably has access to all the files in the system. So I just wanted to give the full picture and let people understand like the pros and cons, because I don't think there is a right answer here. Mm-hmm. A bit more supporting the cons, but it's not like strict environment variables are insecure. It's a bit less secure than files, in my opinion.
Mm-hmm. So if it's super easy to set up pods in the environment, could you not set up an additional pod that would be like that would decrypt everything for you kind of on the fly inside of your cluster there?
Sorry, can you repeat it? I didn't follow.
So if you have, instead of having to set up a whole KMS architecture or using a KMS to decrypt the data, could you set up a specific pod inside of your a Kubernetes a pod that would decrypt the data for you kind of on the fly?
So this is kind of what we do with Kamus, just in scale, because if you need to do it per pod, you will need to configure per pod the right permission to talk with your KMS and decrypt the system, and it's really hard to scale. Mm-hmm. So Kamus just had to do it in a way that you can add it to any pod in your cluster without getting into the mess of, do it manually per pod. So it's pretty much the same, just in a more robust manner.
Okay. I'm working in a DevOps environment. I'm trying to, channel that little bit of developer that I'm trying to develop. How much additional effort is required to set this up, maintain it, and add it to your workflow? What does it take to add this to your already, your workflow that you have already?
So maintenance, there is some maintenance overhead because you need to start maintaining a KMS and all that, but it's relatively small. I think it's not a lot of effort. Like we have Kamus in production for a year and we didn't have any incident until now, and it was pretty seamless. For the developer workflow, it's pretty much the same. Kamus basically give your application, your pod, a file with the decrypted secrets. So basically all your application need to do is being able to read a JSON configuration file. And if the application can do that, it's basically opaque you to this application. The application will not even know that Kamus was involved as part of the flow.
Okay.
Installing it is really simple. We have Helm charts, so you can do this, just Helm install and it's working. And we have a detailed guide explaining how to install it securely using one of the KMS provider.
Okay.
Yeah, they have a really nice architecture flow too, showing like from user what actually happens, like at what level of encryption, where the data goes. It's interesting.
Yeah, it was part of the threat model. We try to give like a whiteboard flow, and I will be really happy if someone will contribute a PR with the new threats. It will make me really happy. This year.
Cool. So, how does you mentioned Travis in here, Travis.ci. What What was that the inspiration for Kamus to be able to be deployed?
Yeah, Travis worked in a very similar manner to Kamus. Like this was the inspiration, as you mentioned. Mm-hmm. In Travis, you can basically have a public key for each repository on Travis. So you can encrypt your secret using the public key of your repository, and then only builds for this repository will be able to decrypt it. So this is what lets you, as an open source project maintainer, encrypt something, put it out there on a public GitHub repository, and don't worry about people being able to decrypt it, which is pretty amazing when you think about it, that you take something really sensitive and just put it out there encrypted, and you know things will be good.
Okay. So I'm looking at your threat model here for if you're on the slide share, it's on slide 54. So your encryptor and decryptor are separate. They're not together. So you can either have the decryptor, or you can have the encryptor. It would seem to me that if I was a bad guy, I'd want to attack the decryptor, because attacking the encryptor, you could do that, I guess, and just make it use a weaker encryption framework. But where do the encryptor and the decryptor reside? Is the encryptor local on the dev's box, or is it somewhere like in a same box? Like you mentioned KMS, is it in the same box? Does the pod call or does the pod call a different service?
So we have two pods on the cluster, one handling encryption and one handling decryption. And as you mentioned, the decryption is the sensitive one.
Right.
And the idea behind separating them, so you can have the encryptor pod exposed outside the cluster, and the decryptor only accessible inside the cluster. And this allows you to lower the attack surface and make sure that even if a hacker was able to possess a token that let it decrypt secrets, if the hacker is not inside the cluster, there is no way she can decrypt those secrets.
Right. Okay. So you mentioned one of the threat models was everything should go over TLS, which is Transport Layer Security. Which version of TLS are you using now? Do you have support for 1.3, or do you? How are you keeping downgrade attacks from happening?
It's pretty much handled by the Kubernetes Ingress, which is usually Nginx. So I think Nginx don't support yet 1.3, but in Kubernetes, all the issues around TLS are a lot more simpler because you have one place to manage them, and you don't have to fix each API in itself.
Very cool. Okay. Let me see. So it's easy to use if you're using Helm. It says Helm install Kamus, and then it's Soluto/Kamus, and then the install guide. You have an install guide for secure installation. That's cool. And then there's a specific blog post for that. So you mentioned in your talk that there were some other things that you'd like to do that it doesn't do. I assume you guys will take code from outside world to help make this better. Maybe you could talk a little bit about some of the things that you're wanting to do to make this more secure to support other platforms.
So supporting other platforms is like the biggest vision, and the main support that I need there to make it happen is people who want to have Kamus and use it on EC2 or FAS or any other platform where you have an identity for your application. And especially we'd like to, have a chat about how to deploy Kamus there, how to do authentication, how to do authorization, because these are not my areas of expertise. And this is like, I think, the main blocker right now of running Kamus outside Kubernetes, this knowledge and design of how to do it securely.
So your last bullet here is FAAS. So it's FAS. You mentioned FAS earlier. What is FAS? I know what SAS is and PAS is and IaaS, but what is FAS?
Yeah, sorry for saying it clearly.
No, it's okay.
FAS is function service. It's the idea of, instead of running full API in the cluster, run full API like on EC2. Sorry for the Hebrew. So instead of having a full API, you can have a really small unit of code, actually a function that can be triggered by various triggers. So for example, you can have a function that all it does is getting a user input and put it in the database. So the trigger for this function is an HTTP request, but you can also have a function that is triggered by something that is written to S3 or a trigger that is from SQS or a lot of other triggers. And what is so unique about FAST or function as a service is that you take all the overhead of having a full-blown service running all the time, and instead of that, having your small unit of code running only when you need it. So if you have a service that only handle request like one time a day, instead of running it 24/7, you can have a function that will run only on this time of the day when someone needs it. And this is a really huge change in how we do things. And it's like Kubernetes, it's a new way to do things that is fundamentally different from what we did before.
Okay. It's an on-demand kind of thing.
Yeah, it's on demand and it's kind of triggered to a lot of things, and it's really small. It's not like huge API.
Right. We're just getting smaller and smaller now. It's like, used to be full-blown VMs, and now we've moved to Docker images, and now we're moving to a serverless environment. Now we're moving to on-demand functions and APIs and such. So it's kind of interesting.
But things are not getting better.
Right.
So
they're just getting more complex.
Yeah. But you might think it's good because the hackers will find it harder, but it doesn't have.
They'll just find a different way of hacking all your stuff. So yeah. Let me see. We got mitigations pods, separate pods. Okay. Oh, you got security tests. Cool. Okay. Yeah, I was just looking through some of the. So you have some accepted risks here. So this is not without its kind of risk. You say clear text traffic is still happening inside the cluster. Any pod in the same namespace can mount any service account, and that also means there's pod impersonation possible, I believe. And then you mentioned, and you actually called this out in your talk, that the service account token never expires. Are those things that could be mitigated by Kamus?
So it's not things. It's things that it's accepted risk for the current state of Kamus. I start with the last two, the thing with the service account. A service account is a Kubernetes object that lets you give an identity to a pod. I said that Kamus let you encrypt a secret to a specific application or to a specific pod. But Kamus need a way to know what is the identity of this pod, and we are doing it using Kubernetes service account. And there are two problems with service account in Kubernetes. The first is the token used by this service account, and this is how you identify your pod. This is how you do authentication. This usability token is never expired. This is like by design in Kubernetes. The token does not have expiration, which is a problem and might be fixed sometimes in the future. There are not a lot of things we can do about it besides making sure that the decryptor is not exposed to the internet. So even if a hacker has an access to a service account token, it will not be useful if that hacker is not inside the cluster. And the second is the permissions in Kubernetes are per namespace. So you can so if you have a service account in a namespace, any pod can mount it. So if I go back to the example of you and Amanda working on two different applications and you two have pods in the same namespace, Amanda can mount the service account of your pod and then be able to decrypt these secrets. So it's an accepted risk because, again, this is how Kubernetes work, and the same things is also true for regular secrets. If you have two pods in the same namespace, they can a pod in a namespace can mount any secret in this namespace. So it's not different, and there are not a lot of things we can do to make it better. There are some things we can do, and it's mentioned in the threat model, but it's not easy. And the last thing is about clear text traffic. We decided that the overhead of having TLS encryption inside the cluster is not worth it, because the risk of having man-in-the-middle attack inside the cluster is very low. It's very hard. I don't want to say impossible, but it's very hard to create man-in-the-middle attack inside Kubernetes cluster. And if an hacker is in a position that she can create man-in-the-middle attack between pods, it's kind of game over.
That makes sense. Yeah, I mean, at some point the pod has to trust each other, so that makes sense. So, okay. Let me see. I really like the threat model stuff. I went through some of that before we started the talk. It's nice to see real DevSecOps happening, where people taking the time to do proper threat models. So that's nice.
Good place to give credit. I don't know if you heard about OWASP Cloud Security Project. It's a very nice OWASP project that basically do threat modeling for basic cloud element. So you have the different risks for example, if you have EC2, the risk that you need to think about. And I mention it because I basically take the format from there. It's like the inspiration for how we do the threat modeling.
Mm-hmm.
And it's part of a bigger effort that a lot of people are talking about right now, of threat modeling as code, which I think is pretty cool. And I hope to see more people use it.
Do you have a link to that? We can put it in our show notes.
Yeah. I just do it right now.
Oh, okay. Cool. Well, that's awesome. Ms. Berlin, do you have any other questions?
No, I do not.
Okay. Omer, you spoke in California in January. Are you going to be speaking at any other AppSec conferences or any conferences elsewhere?
So, no, I didn't. I have some small conferences in Israel, but nothing of OWASP right now. But,
okay.
I keep meeting and hope to get accepted one day.
Yeah, I was just going to see when Tel Aviv, B-Sides Tel Aviv was going on. B-Sides Tel Aviv is...
Tel Aviv is, I think it's 24th of June,
mm-hmm.
but less than a month, OWASP Global is getting to Tel Aviv for indefinite. So if anyone is hearing us right now, now is the time to register, because it's going to be a really, really cool event, and I'm going to be there. So if you're coming to it, come say hi.
Do you have a link to that conference too? Because we definitely like to put it in our show notes.
Yeah, I put it also.
Awesome. Appreciate that. Thank you, sir. And if anybody wanted to talk about Kamus, how would they contact you? Is there a good way of contacting you by Twitter or email or something?
Yeah, they can either reach out to me via Twitter, or we have a Slack for Kamus, and I'm also on a lot of different Slack workspaces like OWASP, Kubernetes, CNCF, so you can find me on each one of them, and also reach out to me there, and I'll be happy to chat with anyone about Kamus and hear what they think about it. And of course, we'll be happy if you give us a star on GitHub. We are really close to 300, and we would like to gather.
Cool. Okay. So on Twitter, you're at Omer, Omer, A-L-H. So O-M-E-R-L-H, right?
Yeah, I'm putting it there. I'm putting us on the notes.
Cool. All right. Very awesome. I have a couple spare weeks here. I'm going to, try to set up something in my house and just try to learn Kubernetes, because it's something that I see every once in a while, or I just like to learn more about it. So I think I'm going to try setting up something in my office here to play with. So cool. Thank you for coming on. I appreciate the somebody seeing a need and filling that need with something to help at least address a lot of the issues. And I'm glad that it's going to be a collaborative environment. So if anybody's interested in shoring up some Kubernetes security, you can always check out the GitHub and everything and donate some code. So awesome.
And thank you very much for having me.
Yeah. Thank you for coming on. So, all right. So we'll do our little bit here at the end. Ms. Berlin, if people wanted to discuss, hackers' health with you, or, just get with you and talk about security, how would they go about doing so?
As long as you don't want to talk to me about Kubernetes, you can, on Twitter, it's InfoSister, INFOSISTIR, or at Hackers Health.
Awesome. Okay. Mr. Boettcher is at work and obviously couldn't join us, and he was greatly missed. You can find him at Boettcherpwned, BOETTCHER PWNED on Twitter. He's also one of the lead developers for Log-MD, and you can go to log-md.com and find out more information about what that is. Forensics tool helps you set up your logging properly on Windows boxes to find malware potentially, or detect malware better. The podcast, you can find BrakeSec Podcast on Twitter at BrakeSec, BRAKESEC, and you can follow me on Twitter at BryanBrake, BRYANBRAKE. And, last week for us was 2 days ago, because we're recording this on a Monday morning, I mentioned a conference that I'm doing, and I'm still freaking out a little bit about that, called InfoSec Campout. So here in the Seattle area, we have a campground. I've already registered some spots, and if you're interested in checking that out, it's going to be the 23rd through the 25th of August, the conference being on the 24th. So if you're interested and you want to come and camp out with us and eat some, marshmallows and very unhealthy food, hot dogs and such, and, tell hacker camp stories around the fire, check out infoseccampout.com. Miss Wendy and I and Matt, who are the organizers, also of the nonprofit. We're also looking for sponsors. As a matter of fact, this morning, somebody just hit us up for potential sponsorship, so that's kind of interesting. We do have a nonprofit if you want to feel good about giving money to people and you don't want to give it just to some ugly corporation. So, we can, if you're interested in sponsoring that, we can definitely, make arrangements for that to happen. So infoseccampout.com. And, I thank Miss Wendy for posting that GitHub page, cause that was pretty awesome. We have a Slack, so if you are interested in Kubernetes or container security or cloud security or network security or incident response or logging or what have you, we have several channels on our Slack, on the BrakeSec Slack, if you'd like to join us. We also have a book club that's going on. We're still doing the hacker, the Christopher Hadnagy book, Human Hacking. We have a European and Asia Pacific book club that happens on Saturday mornings here Pacific time. We also have a Wednesday night book club that meets every other week for our US folks. And we have a sim club which meets on Monday nights. So if you are interested in learning how to tune your sim better, or you hate Splunk and you just want to vent a little bit, Miss Berlin knows about that. So you can join our Slack by invite. Go to BDS, email bdspodcast.podcast@gmail.com, or you can hit us up on the official Twitter at BrakeSec. So that was it for this week. This will go out on the weekend of May 4th. May the 4th be with you, or whatever it is people say. And go ahead, Ms. Berlin. Oh, you didn't say anything? Okay, I thought you might have said something. Okay. Well, all right. That was it for Breaking Down Security this week. Have a great week. Be nice to one another. Take care of yourself, because you're the only you have. And we'll talk to you again soon.
Bye.
Thank you very much for having me. Bye-bye.